these are the products we make here, the beams and blocks. The beams are specifically the T-beams. We make them here. We have a manufacturing plant with us here.
Yeah. Hello and welcome to today's video. In this one, we are going to talk about beam and block technology, and specifically we're going to talk about the T-beams and block. As you all know from previous videos, we know Kingdom Precast as the leading manufacturer of precast concrete panels. But today we are introducing a new product that they are launching into the market, the T-beams and the blocks. So in this video, we're going to talk about that technology. We have a demonstration here, and we'll be able to talk about the T-beams, the blocks, and how they help you to build a suspended foundation or a suspended slab. So, Bwana Wambua,
Yes.
welcome to today's video.
Yeah.
There are various technologies people use to build slabs.
Yeah.
We have the conventional, where we have concrete and steel. We have precast panels with steel beams.
Yeah.
But today we are talking about the beam and block technology.
Yeah.
So kindly tell us how you manufacture them and how they first of all help people to build their slabs.
Yeah. Again, I would say good morning, good afternoon, and good evening, depending on where you are watching us from. We are again grateful because we have viewers from all the walks of life, Africa, beyond Africa. I get calls from all over. So that's why we are grateful for the many people that follow what we do and the many people who have interest in what we do. Actually, I have helped a number of African countries to set up what we do here because, again, it's a revolution. If we're able to bring change in our time, then we are grateful. Now, to your question, Nick, is these are the products we make here, the beams and blocks. The beams are specifically the T-beams. We make them here. We have a manufacturing plant with us here.
Yeah.
And simply the way you make them is you pre-stretch the wire and you make your concrete. That is, you have your aggregates here. And then the process that you make with is you pre-stretch the wire, then you make your concrete. Now, when you make it, you pour into the casting bed. It's a highly tensioned bed.
Yes.
So then you vibrate your concrete.
Okay.
Yeah.
Now, like in a typical T-beam, how many steel tendons does it have?
Oh, we have 4. So we have 1, 2, 3.
Okay.
Then this is 4.
Yeah.
So we have 4 tendons.
And the way we've set up this demonstration,
Yes.
is this how they will be laid out to make a slab?
Exactly.
At a particular site?
This is how they are laid.
Yeah.
So depending on the nature of the project, assume, for example, you're doing a suspended slab. So you have your concrete beam. Assume this is your the conventional beam.
Yes.
Then this will lie on top.
Okay.
If you see like this block here. If you remove it here, there is space.
Yes.
So simply, you will have your beam round. Then this will help you cover the space. Then once you do that, on top of this, now you will do a concrete topping of 50 millimeters.
Yes.
Yes. So it reduces the time frame that you should do the project. It reduces the formwork that you have to do. It's simply going straight to the point.
Yeah.
Yeah.
Now, why would someone invest in a T-beam and block slab when, for example, if you use the precast panels and the steel, is there something better with this technology?
Oh yeah, even the times that we've been doing the steel and the panels, I was always looking into this. Actually, that's why I always say God is great, because I started looking into this long way ago in 2019, but is it now 2025 that we're seeing it?
Yeah.
So why we have those two, we choose to go for this option than the old one. This has more strength than the previous. Well, the other one, the strength simply lies on the steel that you use.
Yeah.
And you see, what was limiting on that one is we have different people with different knowledge on the strengths that steel carry. So sometimes when you get someone who is not so much or does not have much of knowledge on balancing the steel and the precast, it's a challenge. But this one, everything is predetermined. Once you calculate your beam strength, this one is easy to flow with. So this one is open to everybody. It's easy to work with everybody. Unlike the other, where you need to have your engineers properly understanding the strength of the steels that they are going to use. Yeah, I mean, in that we are talking about the RHS tubes and the likes.
Yeah.
Yeah.
Okay. Now here we have two different sizes of the blocks.
Yeah.
Why do they differ? And do they have different situations that are best suitable for them?
Yes, they do, and the reason why they differ is because of different strength. Different structures require different strength. Like for example, this is a block. This is a 3/8 block wind.
Okay.
And the height is 150. Even the beam is also 150 high. Now, this particular block here, if you're working on a commercial building, this would be more preferred because now you increase your strength because of high traffic. Now, on this other one, this is 545, 545 block, the wind.
Yes.
Now, this one is for people who are building just your own house. There's not much traffic. The strength here is not as much as compared to someone who is doing this for a commercial building. So
like
simply
a mall,
that's
for example.
Yeah, like for a mall, for example. There are situations where you also have to do a double beam for this,
Yes.
or a triple beam, depending on the structure that you're doing. We have our engineers, so always people come to engage. We balance, we look at your structural drawings, then we balance the strength that this gives to the convention. But the good bit is, the strength that this beam has is way far beyond what is needed. Why do we achieve that? We achieve that because we have to make sure once we mold this, we can demold it as soon as possible. So, like for example, this one when you cast today, you should remove it tomorrow.
Okay.
Or latest the day after. But no, the only thing you can do is to make sure it achieves more strength for you to demold it. So it actually has more strength than what is needed, but that helps the manufacturer to be at speed also.
Okay.
Yeah.
So when you say this achieves high strength, I'm assuming it's using the high strength cement, the 42.5.
Yes, actually it's 42.5, and even the wire that we use, it's around 1770 MPS. So it's way very strong.
Yeah.
Yeah.
So that's pre-stressing.
Yeah.
Now, once you've laid your blocks, you've said you do a topping of 50 millimeters.
Yes.
Now, why do you reinforce that slab, that topping, to reduce cracks and to also increase its tensile strength?
Oh yeah, mostly initially people used to do the BRC, although there are people who do that, but we use the fiber mesh. Fiber mesh has more bonding characteristics than the BRC.
Okay.
So we use the fiber mesh. I think I have a bit of this here.
Yes.
Yeah. So this is a fiber mesh. It has more bonding characteristics.
Yeah.
So this is more preferred by the engineers
Yes.
than the BRC. So mostly this is now on your concreting, when you mix with this one. It gives more strength and it avoids, it makes sure you have no cracks at all.
Okay.
On your slab. So this is what we have.
All right. So to recap this section, from here to here for this larger block,
Exactly.
how wide is it?
This is from here to here is 545 millimeters.
Okay.
Yeah.
And this is suitable for residential homes.
Exactly.
Okay.
Yeah.
And from here to here?
This is 380.
300
span. It's good for commercial places.
Okay.
Yeah.
How do you determine the length of each particular T-beam? Is it adapted for each project?
Many people come with their structural designs. So we look into how your beam layout is. So from there, we will make beams hose size is equivalent or matches the spans of your structural design. So mostly that is what determines the length of this. Again, sometimes we make, like, if you look at those beams here and these ones,
Yeah.
they have a length of 6.2 meters. So sometimes
Maximum.
maximum.
Okay.
You capitalize on the longer beams because, like, there are many people who come to us and they want the beams right now. So sometimes you can resize because the nature of project, there are people who decide along the way. There are people who decide before. For you to accommodate that, sometimes you have the longer spans, so you can cut into pieces. Like now, the lorries we are loading here.
Yeah.
We're loading a total of 7 lorries. We went to the site on Saturday. Today is Tuesday.
Yeah.
I think this guy is like, I want the things as now. So that's why you have to tabulate and look into the days to come.
Okay.
Yeah, so that's how you determine the sizes.
Yeah.
Yeah.
So assume I'm a client. I have my drawings, my architectural drawing, my structural drawing. So for me as a client, I just submit those drawings to you,
Yeah.
and then you give me a detailed drawing, including now the beams.
Yeah, exactly. We give you the quote, and again we give you a detailed drawing on how this will be arranged in your project. So we have those drawings on how the lengths that your beams will have, because mostly we use the shorter spans.
Yeah.
So even many times we go to sites because we want to determine ourselves whether the lengths you've given are right as per the ground, not per the drawing. We can give you an estimate as per the drawings, but we come ourselves and measure to be sure what we're supplying you will exactly fit. So then we will provide a drawing with how the beams will be arranged and the blocks.
Okay.
So that is what your technical people will use. But again, if you don't have technical people, we offer that support.
Yes.
Yeah.
Through your engineers, your structural engineers.
Through our structural engineers.
Okay.
We have quite a number of them.
Yes.
Yeah.
In the case of plumbing and electrical conduits, how do plumbers and electricians pass their conduits easily through a T-beam system?
Through a T-beam system, so you will pass your conduits here. You can either use this groove or that, or even on top.
Okay.
Because why we are doing the 50 mm topping is just to cover the surfaces.
Yeah.
So you can use them on the plumbing point. You can cut around, then pass your pipes. Okay. So simply you use the surface, you lay them around, then now you do concrete on top.
Yeah.
That is the essence of the 50 mm topping.
Yeah.
So simply you just use them on the surface.
Okay.
Yeah.
Now, another question.
Yeah.
Why do the concrete blocks, why do they have hollow cores between them?
Oh yeah, this is very good for soundproofing. And actually, if I'm doing this on an upper slab, this will serve very good for insulation. So I will not have extreme temperatures on where I have these such hollow surfaces on top. Again, this helps reduce the weight of the block.
Yeah.
Yeah.
It does like 3 jobs.
Yeah.
Reduce the weight of the block.
Yeah.
Sound insulation and
yeah.
thermal insulation.
Exactly.
Okay.
Yeah.
How does someone save money using T-beams versus the conventional slab?
There are 2 ways you save on this, and the labor is almost reduced to the largest extent. Because, for example, you will realize, assume for a commercial building, you can do the beams in 2 days. You only need 1 technician na watu wa mkono. So it becomes so easy to do that work in 2 days. Watu wa mkono, maybe there will be 5. So that labor is totally reduced. On the same, you save so much on your cost of transport. Yeah. Again, direct cost, this one, relatively, the comparison between doing this and the conventional, it's around 20-25% saving. If you do the cost per square meter of the conventional and the cost per square meter of this, You know, in this one, you don't use the props. You don't have formwork.
Yes.
So your work is simplified. And I think that's why many people are totally and completely into this.
Okay.
The demand for this is quite good.
Yeah.
Yeah. You remember we had to wait a bit so that we have at least some, because we just make and they go. So it's totally good and,
Yeah.
and comparable. Like now, the lorry we're loading here, the owner is on the 3rd floor.
Yes.
I think we will showcase this building on some other day on YouTube.
Okay.
He has been using the conventional. When we brought this, we just did the simple mathematics. Like, how much is this? Because I've already done the other slab. Now, how much is this new one? The cost is totally different. So we didn't have any other thing but to use this.
Okay.
Yeah.
When it comes to suspended foundations, how do you go about using T-beams for that particular case?
Oh yeah. So mostly and many times, one thing, there's an error I've seen before, and I promise not to go by it, because again, you look, these are structures you're building for people, and you want people to leave these structures for their generations to come. So simply, the best way is to do your your columns from the foundation. Once you do your columns, do a ground beam. Then now place this. I see sometimes people place this beam and on another beam, on another column. Now, you as an engineer, you will tell me, you have also too much strength on structures.
Yeah.
You see? So even on the ratio of concrete to the ratio of steel, when you've closed down to the surface area that your concrete is going, the strength has a mismatch. So simply the best way is do your column to its strength properly, do your beam with its strength, so that even if there are anything to do with earthquakes, seismic and all that, your structure stands.
Yeah.
That is the very, very best way.
Okay.
Yeah.
Now, since this is a technical topic, as we've discussed, I'm sure some clients would prefer to use their structural engineer to come and liaise with you.
Yeah.
So can their, for example, if I'm a client, I have my structural engineer who has done my drawings.
Yeah.
Is it possible for my engineer to come and speak to now your structural engineer?
Yeah.
And talk about the loadings?
Oh yeah.
So,
actually,
on my behalf now.
Yeah.
Because I don't have that knowledge.
Yeah. But it's also good you as a client to listen.
Yeah.
But that is exactly how it happens. Even on the projects we're doing now, your structural engineer will come and our structural engineer will meet with him. We will discuss the details. There are many sites we've gone and maybe their structural engineer never came. So we also we make our recommendations, which it's a win-win because our recommendations are for good. Yeah, so it is always open. That's the best way. Come with your structural engineer. We have our structural engineers. Now we discuss together.
Okay.
Then we match the loads.
And at my site,
Yes.
do you provide a technician to come and inspect the installation process?
Yes, we do. We do. Although largely now this has become something which is common. But in any time you need a technician, we always provide that. Yeah.
Okay. Transport. In a typical lorry, for example, this one that you have in the background, how many T-beams does it carry legally to a particular site?
Mostly, I will not say on the quantities because again the beams vary in size.
Okay.
Now, because like for example, you find this lorry has sometimes beams that are 1 meter, other beams that are 5.5 meter, other beams that are 4 point something meter. So sometimes we give the tonnage. For example, 1 linear beam, 1 meter of a linear beam is 30 kgs. So we will total the number of linear meters you have times 30. So then we will calculate what the capacity of the truck. Then once we calculate the capacity of the truck, now we will tell you your truck is able to carry this these quantities.
Okay.
Because the beams are not the same.
Yeah.
Yeah.
So talking about the weight, you've said that per linear meter for the T-beams is 30 kgs.
Yeah.
Now what about these blocks for the 380 millimeter and the 585 millimeter?
Oh yeah, this particular block, the longer one, which is a 545.
Sorry, 545,
The,
yes.
yeah, 545 has 16 kgs per block.
Okay.
And the 381 has 10 kgs per block. So maybe someone is tabulating their mathematics when we're not there. The block will be 30 kgs per linear meter. I mean, the beam will be 30 kgs per linear meter. This longer block will be 16 kgs. And this shorter block of 380 will be 10 kgs.
Yeah.
Yeah.
So from there, the client can be able to know how they can load their lorries.
Exactly, how they can load their... Again, I repeat, we said you will measure the length of these ones from beam to beam. Mostly, you will not use the shorter side of the beam like the inside. You will gower your beams along. Maybe if your beam is 200, you will take 100 from this side and 100 from that other side.
So
Yes.
if we say this is 200,
Yeah,
they'll do 100 here
yeah.
for this. Say this is a room, and
Yeah.
then another 100 for
Exactly,
this particular
on
room.
this particular one. Then the same you do.
goes on.
So when you arrange your beams, they will be very continuous.
Yeah.
Yes, yes.
So
Yeah.
now, do you transport to every part of Kenya? Is it possible?
Yes, it is possible. And again, I've said before, not only every part of Kenya, because we've taken these things before to Zambia, Seychelles, and Uganda here, Tanzania. So we transport beyond Kenya.
Okay.
Again, we are grateful.
Yes.
Yeah.
So how do I get in touch with you now if I need these services apart from precast panels?
Oh yeah. We're still having the same number that we've always used on the precast products. We're still using the same office where we have. It's only that the site here needed a bigger space. So where we have Kingdom Precast, the one for precast, the place is already occupied.
Yeah.
We couldn't have this there. But it's actually 5 minutes drive from our main offices to this. Many clients, when they come here, they tell us that we should make this the headquarters. So
Yeah.
we are considering that, but for the purpose of accessibility, we still remain there. That is where we always are. So you can come and engage us. You can call us on the numbers that we've always given. That will always be good.
Okay.
Yeah, we're always available for a
Yeah.
chat.
Yeah.
And people are always welcome for a site visit. Come see, come learn, come understand.
Yeah.
Because the way the world is going is the precast way is the way to go.
Yeah.
Yeah.
So guys, you've heard it from Sami Wambua of Kingdom Precast. We've talked about the T-beams and blocks technology. Now, in the next video, we'll go to a particular site where they are installing these T-beams so that you can have that practical knowledge and see how they are installed. So thanks for watching till this point. We shall see you in that project.